Hello and welcome again as we look at yet another multiple choice question for IB Chemistry. What is the orbital hybridization for each of the oxygen atoms shown in the molecule below? And you see the choices here and the molecule here. The choices talk about sp2 and sp3 and sp orbital hybridization. Now if this entire topic has you confused, then you should go back to the lesson on the card above and review the topic fully. But there is a short way to arrive at this answer, even if you're not very confident with your understanding of orbital hybridization. But it depends upon a good understanding of electron domain geometry. And here is how it works. This carbon here is double bonded to an oxygen, like this. 2 valence electrons of the 6 in this oxygen are shared with the carbon. That makes 1 electron domain. The other 2 electron pairs on the oxygen would make up its 6 valence electrons. These 6 constitute 1 domain here, another domain here, and the third domain over here. So here we have 3 electron domains, and this means that you have trigonal planar electron domain geometry. And when you have trigonal planar electron domain geometry, it means that you have sp2 orbital hybridization. And now for the other oxygen. This oxygen is bonded to a carbon here, and then that is in turn bonded to a hydrogen, with 1 valence electron here shared with the carbon, another one shared with the hydrogen, and 2 other pairs of valence electrons making up a total of 6 valence electrons. These 6 have 1 domain here, another domain here, a third domain here, and a fourth domain here. So there are now 4 domains associated with this oxygen. And 4 domains means tetrahedral electron domain geometry. And when you have tetrahedral electron domain geometry, you have sp3 orbital hybridization. And this is all you need to arrive at the answer for this question. But it's also useful to consider when will you have sp orbital hybridization. And a very good example of when you will get that is beryllium chloride, with 2 valence electrons, each of these valence electrons covalently bonded to a chlorine on either side, giving rise to 2 electron domains, linear electron domain geometry, and sp orbital hybridization. So when you have 2 domains and linear geometry, you have sp orbital hybridization. When you have 3 domains and trigonal planar geometry, then you have sp2 orbital hybridization. And when you have 4 domains and tetrahedral geometry, then you have sp3 orbital hybridization. The answer to this question would be that this oxygen has sp2 and this one has sp3. So that would lead us to the choice of C.